All right, good morning, good evening, good afternoon. Welcome.
What's up?
We're bringing to you the first installment of what we're going to be calling HTML5Rocks Live.
Boom.
A video series talking about...
What are we going to talk about?
I don't know.
Everything.
Building web apps.
Building web apps.
What's new in the browser, and how to do amazing things inside the browser, I guess.
How to do that.
Yeah.
Cool, man.
Today we have a few things that we're going to show. We're going to talk about the new vertical timeline in the Chrome Developer Tools. We're going to talk about device detection, and then we're also going to talk about the file system API and some new stuff for that.
Before we do that, we should introduce ourselves.
Sounds good. Good point.
So who are you? Fine, sir.
My name is Paul Irish. We're all on the Chrome Developer Relations team. I like to focus on the Chrome Developer Tools and cross-browser and all sorts of good stuff.
My name is Boris. I mostly focus on mobile stuff and used to be on extensions.
What's up, everybody? My name is Eric Beidelman, also on Chrome Developer Relations, focusing mainly on HTML5 awesomeness for building web apps.
Nice.
Yeah.
All right, so first, I think we'll just go right into it. I want to show off some new features inside the Chrome DevTools, and so what I'm going to do is I'm just going to share my screen. That should be good. Cool. So I wanted to show some new stuff, and so what I'm going to do is actually going to use a demo that was written by a developer called Hakeem. He goes by Hakimel on Twitter and GitHub. Really good stuff. And so this is a little tricky because you're going to be watching it, and the frame rate won't be so hot. And it's all about smooth graphics, but you're just going to have to bear with me here, okay?
It's a little difficult to show. Yeah.
So what this is a little demo where we can kind of scroll through a list of items, and there's a visual effect as the items kind of scroll into view. Pretty cool. And so Hakeem released this sometime last week, and everyone was really into it. And so I was looking at the code behind it, and I was like, this is cool. And I was wondering if we could actually make it any smoother at all. I've learned a few things about how Chrome deals with hardware-accelerated graphics, and was like, let's try and...
Did you see like visual jank? I mean, were you like actively investigating? Or?
Yeah.
It's a great demo, but...
Yeah. I mean, I did. So we call it jank oftentimes inside the team. Jank is just like stuttering and like the absence of buttery smoothness, right?
The void of.
Yeah, exactly. So yeah, it was good, but I was like, I think we can get a little bit better. So I'm going to show you a new tool inside the Chrome DevTools that we're going to use to kind of explore this. First, yeah, so you'll see it here. Right inside the Timelines panel on the Timelines, there's these two buttons right underneath Resources. And it doesn't look like it's doing much now, but we'll see it in a little bit. Now, right now, to enable this, you're going to have to do a little bit of funky stuff. You're going to have to go to About Flags, where you can turn on all sorts of good stuff. And you're going to search for Developer Tool Experiments. You enable that. And then back inside your DevTools, you click on Settings. And down at the bottom is all these cool experiments. Now, of course, all this stuff is kind of super experimental. If it breaks, too bad. But this is the new vertical overview mode in the timeline panel. And you'll be seeing it soon anyways. But here's kind of what it does. First, I'm going to keep it off. And I'm just going to record. And I'll go down and scroll a little bit. OK, cool. Stop recording. And now I can click and I can drag. And I can see some things. Mostly it's just paints all along the side, and we can see how big the paints are. Here's a scroll event. It looks like this scroll event is actually taking up quite a bit of time. How long is this? 211 milliseconds for the entire duration.
So Paul, is that the like callback for the scroll, or what is that?
So yeah, the self time of the actual event itself is pretty very small. But what it does is considerable. So that one scroll event kicks off a lot of recalculate style and layout. So recalculate style and layout is basically we're matching all the CSS against the DOM and then recalculating all the geometry of the page. And when you see recalc style and then followed by layout, and that pair going back and forth, there's usually an ability to optimize that. And so we're going to look into what we can do there.
So that's sort of an instant red flag
Yeah.
in your web app.
Yeah, exactly.
So could you talk a bit about the yellow bar? It has the bright yellow and then the less bright yellow?
Yeah, the beginning is the self time, right? So if I'm highlighting over here and we have the self time, it's basically, you know, that sometimes you'll see this with event handlers. You also see this with maybe with the Ajax. What the actual event was the very beginning, and then its effect is captured by the whole thing. So the callback or the scroll handler and all its effects. So what I'm actually going to do is I'm going to clear this out. I'm going to switch over to vertical and record. Now it's a little bit different. Okay.
Oh, that's nice.
So I'm going to do that once more because I'm okay. Here we go. So this is a much different view, right? These are all frames. And so one thing you'll notice is along the top is a time from 0 to 4 seconds. But if we zoom in to the frames, you'll see that the time scale is actually the length of each frame. And now, what's the optimized best frame rate that we could have for our
60.
60 frames per second. And how many milliseconds per frame is that?
16.66 repeated.
Correct.
You're a math major, Boris. That's good, man.
Blue ribbon. All right. So in an ideal world, you have 16.6 frames, 16.6 milliseconds per frame, nothing more. And everything, your entire everything just happens inside 16 milliseconds. Now it often happens that you take more than this. And so we've just dived in, and we can see that these frames are actually taking 40, 60, 100, 80. They're a lot more than just that 16.
That's no good.
But we're able to see exactly what is happening inside that time. So we have a scroll event, and it's doing a bunch of stuff. And so I can click in and see what's going on inside that scroll event. So this is there's a lot of things happening, but it looks like.
Sorry, are we projecting that? Are we projecting the screen right now?
Oh no, but we'll switch over to that.
Can you switch over to the screen?
Cool. So this is inside scripts panel, but I'm just going to bring this up inside my code editor so everyone can see it. We have a scroll handler that is bound to update, and in update we do all this magic. And that's good, but one thing that I learned like a few months ago is it's actually quite bad to bind to either scroll or resize. Those events fire quite a bit, and so actually a better way, and typically you'll be binding those so that you can update the UI of the page. Yeah. But we have a first-class API designed for redrawing the UI of the page when the browser is ready, which is called
RAF, RequestAnimationFrame.
Yeah, RequestAnimationFrame.
Everybody's best friend.
Or RAF, as we.
So let me ask you a question. The scroll and resize, those always fire quite more often than 60 FPS, right? No, or
they fire a lot.
We'll assume so. They fire way more than you should be updating a UI,
yeah.
right?
Browser engineers really just don't like it when you bind to them.
Yeah. Users don't either, because that means there's jank, word of the day, inside of your app.
Yeah. So what we're going to do is we're actually going to change the implementation. Instead of binding to scroll, we're just going to bind to RAF. So we're just going to the browser's going to optimize that to 60 frames if it can. So I'm going to take this scroll event, and I'm going to copy in a little RequestAnimationFrame shim, and then I'm going to replace the scroll with some RAF loop. So this is just a recursive loop to call RequestAnimationFrame.
So for those not familiar with RequestAnimationFrame, I'm not seeing so set timeout, right? People use set timeout. There's a time that you like recall your callback. That's not the case with RequestAnimationFrame. Can you explain that a little bit?
Well, it is a callback.
Right, but you're not passing an explicit time that you're calling the callback.
Yeah, you're just saying, hey browser, you take care of this. This is the function that I want to be called, and you call it as much as you can. And one of the things that's happening is is the browser's starting to get smart. So if your callback starts to take so much time, it's actually going to optimize your animation for 30 frames a second.
Nice.
So you're always blowing past the 16.6 milliseconds, and it's going to say, hey, you know, we're just going to have you be 30 frames per second. Now, the big thing about these 30 and 60 numbers is that your monitor refreshes at 60 hertz. So Chrome is actually able to make sure that your canvas or your CSS changes are being painted to the screen and synchronized to the refresh rate of the monitor, which means it's as smooth as it can be, which is really powerful. So this is like the best way to get the smoothest graphics.
Yeah, cool. The other benefit too, right, is that if your app isn't like visible to the user, RequestAnimationFrame will stop calling that callback altogether.
Yeah.
Right. So if the users can't see something visually being updated on the page, then there's no reason to waste that CPU or to waste that extra calculation.
Right. And so this is one of the cool
another benefit.
cool things on Chrome for Android is that Chrome for Android is the first mobile browser that has RequestAnimationFrame. So if you have some like cool canvas loop using RequestAnimationFrame and you switch to another tab, that is not still running. We just
super
completely
important for mobile.
kill that out.
So here you're not bound to any event handler, so this will re-render all the time, regardless of if you're scrolling or not, right?
Correct. A more
Do we like that?
No. This is good question. This is a very like naive implementation.
Mm-hmm.
In an ideal world, we would have kind of scroll kicks off this RAF loop,
Right.
And then at some point we like debounce the scroll event, kick off RAF, and then cancel out RAF when this scrolling is done.
Yeah, so we might timeout or something.
Yeah. So there's a way to kind of like have scroll and resize, kick off RAF, but work together.
So RAF is pretty. The calls are similar to set timeout. You can cancel, you can request.
Yeah.
It's just that time difference that you're not passing in.
Yeah. So we'll go back to the timeline, and now that I have RAF in, before you kind of see all these uneven bars, and but there's not a lot of context. Now with RAF in, I saved. I'm going to refresh. Cool. And once it's in, I'm going to record our new thing, and you'll see quite a bit of difference down in this timeline. So
nice.
It's already moving, and there's a lot of bars. So I'm not touching anything, and the bars are just going. And so you can see down here, there's a lot of animation frames firing. So this is pretty cool, but what we're able to see is that the browser is giving us an indication of how long all these animation frames are taking. And so we're able to see when there's big spikes, that means that it's taking much longer than it should, and we're not able to hit our 60 frames per second. So in an ideal world, 60 frames per second means that all these bars are just completely flat.
Mm-hmm.
But here we have spikes.
This is cool. So this is like a visual representation of your code right now.
Yeah.
Right?
And so like these spikes are jank, right?
Yeah.
And so
let's get rid of that.
We're going to kill that jank. So I'm going to click into, I'm just going to zoom in. And you really got to zoom in pretty close. So that looks pretty good. And I'm going to switch, let's see. Okay. This looks pretty good. We have this animation frame. It fires. It takes quite a while. And we're going to look into what's going on. We got recalculate style going on inside of that, a few layouts. We click into the recalculate style, and it points to this line in particular, which is offset top, offset height.
Uh-oh.
Yeah. There's a few DOM properties that cause a reflow, and that's essentially what's happening, is that the browser has to say, hey, I don't know what the offset top and offset height is, but I need to recalculate the entire geometry of the page in order to give you, the JavaScript, an accurate number for these two things. And it has to do this, actually, the loop that it's in is for every single item in this list on every single frame.
Wow.
Seems really wasteful.
It's totally wasteful. It turns out that offset top and offset height do not even change for any of these for the entire thing.
This is why it's hard to be a web developer right here. This sort of thing.
It's true. All right, so So let's see. I'll go to kind of the next iteration. This is where this ended up. So I spent some time with this, and we ended up here, where we actually cache some of these numbers. So let's see, I think the scroll top, we cache, and we make sure that if the scroll top has not changed since last time we went into this RAF loop, we just quit immediately.
That's good.
And then we actually do two loops. One loop we do to go and get the offset tops, and then we do a second loop to go make the changes. Now, the reason that we actually do two loops is back on HTML5Rocks a while ago, we talked about reflows and optimizing for those, and we talked about that pattern of recalculate style layout, recalculate style layout. And here we were asking for what is the offset top, and immediately using class list to change the class of some DOM elements. And then we would just do that, and then we would do about 100 per loop. And so that is totally wasteful. So here we're able to get all of our information out of the DOM in one loop, in one pass, and then make all of our changes in another pass. And that's really the most optimized way to kind of handle that situation.
It's interesting that something like two loops, you wouldn't.
Yeah,
it's not intuitive that two loops would be more efficient oftentimes than touching the DOM like you would in a single loop.
Right.
But maybe that's something you have to do. You have to consider that, right?
Yeah.
DOM is the bottleneck here.
DOM's the bottleneck, not like two loops. I mean, I could make it do 10 loops, and I'd probably still be more effective than the back and forth inside a single loop.
Calculate a Fibonacci sequence in there someplace.
So basically, what you're doing is you're getting the updates and then doing the renders.
Yep.
Separately.
Yeah, exactly.
But how does a web developer know which of these things cause a reflow?
I was just thinking that, like is there a best practice? Yeah.
Do that.
Okay, so that's fair. So one, you could be like DOM properties that cause reflow. Just use your favorite search engine and ask. And the best resource on this is on this site. This is actually a Chrome engineer, Tony, and he just looked into the WebKit source and found out that these are all the properties. These are all the methods, and all these things force the browser to go ask, and they all force a reflow. So if you ask for all these things,
wow.
So that if you know that, and then right, because you do.
Step one.
And then you're over here. You're seeing recalculate style, layout, recalculate style, and this is actually pointing to a line number, right? A file and line number. And I click 44, and it highlights this line 44 right here.
Good point.
It's a pretty good indication. And so if I move over, this is the new and updated one, and I'll do a timeline recording of this. Good. Now it's hard to show on the screencast, but we're a little bit smoother, and inside, yes, that's what I wanted. So we only have a single recalc style and then a layout, as opposed to back and forth and back and forth. So that's exactly what we want to be able to see, is that we're only getting a single one of each per frame.
Yeah.
That is optimal. It's hard to get.
Remind us what we were seeing before. We were seeing sort of orange mixed in with purple, or were we seeing higher bars?
Yeah, so orange is style. Sorry. Yellow and orange is script. And then purple is rendering.
That's the browser doing its thing.
Yeah, and so it's hard to sometimes say what the rendering is, whereas the script is basically always your code. But when we see this purple back and forth, recalc style layout, that's just a bad idea. So you're able to kind of do these hovers here and see that we have a call stack or an update anim loop, and get an idea of where this is happening. And so the cool thing here is that we're able to get some information from the DevTools on what exactly and where exactly we can optimize better.
Yeah, that's great there. I don't have to memorize all those properties. The DevTools can kind of help me there.
Yep.
Yeah.
Can you go back to the timeline again? I just want to just show people that we talked a little bit about this before, but RequestAnimationFrame is continuing to fire, right, regardless of if you're scrolling these lists or not. So it probably is like one of these sort of best practices that you should consider. Like if user's not engaging with your page, then you should probably cancel that and not waste that.
Yeah.
As callbacks.
Yeah. If you're able to, I think the quicker that you're able to say, I don't need what's going to happen inside this RAF callback to happen, and just cancel out of that loop, the better. And so that's what we ended up in this thing.
Right, but of course, if you background it, it's not going to fire.
Yeah, and if you're in another tab, you're totally good.
Yep.
So so you should go check out this. Just Google for this demo and check it out, because it's gotten a lot of other community additions after all. Since the last week or so.
It's called Silly List Scroll Effects?
Yeah, I think it's actually since been named to Scroll.js.
Of course there's a .js for it.
Yeah, of course. But it's really, whoa.
No, those are pretty rad.
That's cool.
Yeah,
and unfortunately, the screen, the Hangout doesn't do it justice, but...
So go check it out. And if you want, go find his GitHub repo and revert back to the very original first commits, and then you'll be able to see the difference between the original one with a considerable amount of jank and the new ones, which are smooth.
We don't like jank.
Awesome.
That's good.
That's cool, man. Yeah. Vertical timeline, awesome.
Yeah.
That's gonna, again, in the DevTools experiments, right? So not in by default yet, but...
Yep.
And this is Canary, right?
Yeah, I'm showing this in Canary, and you have to turn on 2 separate experimental flags to get it. But it'll probably be coming out into the main release pretty soon.
Cool, man. I look forward to that.
That's cool. Boris, do you want to show off your cool device.js?
Sure.
What'd you make, Boris?
I made a library.
Yeah?
Dude.
It's called, well, let me talk about maybe briefly what sort of spurred this on.
Hello, test. Cool. So basically, you've probably heard of responsive design. Yeah?
I have.
Heard of responsive design?
I have, but you could remind me what it is.
Sure. So it's actually pretty broad, but the most sort of surface level of the basic idea of it is you use CSS media queries to check the width of your device and style the page appropriately.
Yep.
So if you have like a really large screen, you make it all fit well. If you have a small screen, you make it compress down and do the right thing. So there's a nice gallery of pages that do this. If you go to MediaQuery.
Yes.
Could you do that, Eric?
Let me type for you.
Please type.
Turn it back on, Paul.
I'll just turn the screen share back on. Yeah, so MediaQuery.es is a nice gallery of responsive. Oh, it's actually one of those funky, delicious URLs. Probably not this one. Here.
Boris, you have to show and tell your own show and tell.
All right, here we go.
There we go.
So this page is a gallery of a bunch of responsively designed sites. And you can see if I resize, this site itself is responsively designed. But if I go to a particular example, it also has this feature where once it loads, you'll see that as I resize the browser, the page starts flowing in different ways. And what's happening basically is there's a way to turn on device width specific CSS.
Sure.
So that's great, right? If you want to customize the way things look. But if you have like an M.dot site or a specific tablet site, this doesn't really address anything. And there's good reasons for doing that. Like you might want to have better performance, like mobile specific performance optimizations, for example, or you might want to load custom JavaScript.
Yeah, you're gonna have different features depending on like you're not gonna have a drag and drop file upload on your phone site, right?
Right. So there's good reasons to use responsive design, but there's also good reasons not to use it depending on your situation. So there's a bunch of approaches you can take. The common one is server-side user agent detection, right? So things like Wurfel. We can just load it up here. Wurfel. It's a really old school project, but still being maintained quite actively. It goes back to the days of WAP. So if you guys remember,
Oh boy.
this is WAP was the precursor to HTML on mobile devices. Anyway, these guys have a huge database of devices and what their capabilities are, essentially. There's similar other projects like Device Atlas. And this is all kind of dark secrets, like black magic type stuff, because there's just so much complexity with user agent parsing to do it right.
So could I ask you? Thank you, Paul. Can I ask you a really important question? So
Sure.
User agent detection. There's a lot of people say it's the devil. People say it's good.
Mm-hmm.
What's your opinion on it? And should we be doing it in 2012?
So that's a good question. I think the debate is still pretty much open right now. The main reason it's still so common is on the server side, there's basically nothing except for the user agent that you can know about the browser that's hitting you, right? So that's all you got on the server. And for performance reasons, you want to do things on the server in the initial loading stage, right? Like on the client, if you're doing things like feature-based detection to load a specific layout, you're inevitably doing a redirect, right? Or some sort of dynamic script loading.
Yeah.
So that's going to have some sort of performance hit.
Some latency cost, yeah.
Some latency cost. Mm-hmm. So device.js actually takes that exact approach. So it does client-side detection based on media queries, which is for browsers that support media queries much nicer than just relying on the server. So you can say things like, if I have this particular width, load this version of my web app, right? So of course the trade-off is performance, but you end up having a much more future-proof solution that's based on feature detection, similar to Modernizer. So this is device.js on GitHub.
Can you show the GitHub page?
It's right here. Yeah. And basically the idea is up front you can follow a semantic approach, and here you can say use the link grel alternate tag, which sort of specifies the list of all the versions that your web app should specify. And this is great for crawlers. It's also just generally a best practice that semantically says this page has multiple versions.
Yep.
And here
it's really if you have multiple versions of your site or app, like this is the best way to semantically represent that.
Is this so I haven't really seen this before. Is this a new thing? Are people doing this?
It's really old, actually.
So yeah,
really? Okay.
if you look in the spec for like HTML4 spec,
back to 4.
Yeah, we'll go back to 4.
Okay.
It's in 5 too. I mean, I don't want to be too retro. But link rel alternate, it's like link rel alternate means this document is available for a different media type.
Yeah.
And the media type is defined in that attribute, and it's a media query.
Right.
So that's what we're doing.
It's great that we're reusing these old sort of paradigms and semantics that have been out for a while, but for something new.
Yeah.
So there's some new stuff here too. So in the old school days, you would say something like handheld. There used to be this media query type, and it was handheld. That kind of is not really well supported. It didn't really work so well. So one thing you'll notice here that you probably haven't seen is this. And what I'm doing here is creating a media query that should exist. It doesn't currently exist except for in Mozilla with a Moz touch-enabled flag. And basically the device.js library just makes that happen for you.
So as far as like what device.js does, it reads these link tags and does something?
Yeah, so the idea is you include device.js here, and it'll parse the link tags in your page. And given these media attributes, do sort of the right thing. The right thing being it redirects to, so first it checks which version you should have, right? And you would have these links in all the versions of your page. So it checks which version you should have, and it compares to your current version based on the URL that you're currently on. And if you need to redirect, then device.js will redirect you. And that's it.
So to clarify, like if I hit the desktop landing page on my mobile device or something, it's going to redirect me to the mobile version that I've specified with device.js.
Yep.
Okay.
So I can show you a quick demo. So here I've got a sample app. It's linked to from the GitHub page, but the default landing page is just a redirector. So if I go to sample, I get redirected to the desktop page. If I try going to the phone page, I'm getting redirected to the desktop page. And the same thing will happen on mobile. So here's my little setup here, and you can see it's the same exact URL. And if I go to the root page, I get redirected to the phone version. And this is all based on the media queries that are specified in the link alternates. So I can also go to the desktop page. Oh, whoops. This is interesting. So anyway, that should definitely work. I'm not sure what happened there. So that's the idea. And of course, in some cases, you might want to like override the version that you want to load, right?
Yeah.
Like for development, or if you like generally you probably want to provide a way to specify the version that you want to use. Like,
so if you want to override it and be like,
Yeah.
you know what, I thank you very much for bringing me to the phone view, but
Right.
I want the desktop view.
Yeah.
right. So that's not to say that you shouldn't provide the functionality that your users need on all of your versions.
Right.
But it's nice to have an override. So
Yeah. It's,
I've basically in this little demo I've provided links, and if you can show the screen share of this. So there's a phone version and a tablet version, and you can see if I go here, what's basically happening is there's a device equals thing in the URL.
Force equals.
You can see device equals desktop here,
Oh, I see.
and then when you click that particular version, then it'll redirect you with force equals 1 so that it doesn't attempt to redirect you again.
Nice.
could you kill that with a push state?
Yeah, could
Replace
you
state?
Would you want
Could.
to?
Yeah.
Definitely could.
So using the history API?
Replace state.
Play state, push state.
Can totally do
Party
this.
on.
Yeah, that's good.
Yep.
That's cool,
that's
man.
a good idea.
Can you go? So can you just quickly explain again the touch? So the non-standard touch enabled.
Yeah.
So basically, that's saying if I'm on a screen and I don't have touch capability, then show me the desktop.
Yeah.
Is there ever the case where you're going to be using touch enabled one for something like the tablet or phone, or would you?
You
media
could.
query suffice? And
Right. So the beauty of this approach is it basically scales to any sort of device or form factor that you might have. So if you imagine like some sort of, I don't know, ocular implant thing, like something completely crazy that
Yeah.
all you need is you implement the media query for it, and then you add your link alternate.
I wonder if Google Glass will have a media query that's appropriate for it. My thought would be
Oh boy.
only
What's the
screen.
pixel ratio update?
Right.
Hardy har har. This is cool, man.
So
Yeah.
right now you've created support for touch enabled.
Yeah,
I wonder
basically.
if there's room for more of that.
Yeah,
in the
that's
future.
kind of my hope here, that we don't need to create these things,
Yeah,
but
and
they
that's
just exist.
Forrest, are you trying to push the web forward?
Actually, yes, Eric, I am.
That's fantastic.
That's what we do here.
One library at a time.
That's nice.
Yep. So there's a CR bug that's linked to from the GitHub page. You should probably go to this and start it.
All right.
Only 9 people have started.
Oh.
It's sad.
Maybe we can get. Can we have like 10, 12 people start right now?
All right.
Awesome.
Yeah,
Thanks,
this
guys.
is a great feature. This should be enabled by default in browsers for sure. And you said Firefox has this if you enable it on a flag or something?
Yeah, so Firefox, I think it should be in the stable version, I believe. I haven't tested, but this would, so even in Firefox, I'm not falling back to the Moz prefix.
Yeah.
I'm just using Modernizer actually to check for touch support.
Nice.
Nice.
So that's basically how it works. And I know there's some caveats, some strange configurations under which it won't, but
By the way, speaking of Modernizer and touch, I know I asked you this question the other day, but this will be valuable for users, for viewers. DevTools has the ability to simulate touch events, correct?
True.
Does Modernizer detect those or no?
I gotta do that.
I was pointing out.
Didn't you report that?
I ran into the issue, and maybe somebody else is having the same problem.
All right. So actually,
could you show that?
Can we
Yeah,
show that?
this is really handy if
that's
you're
awesome.
doing
That's
mobile
worth showing right
development.
now. Alright, so I'm gonna.
Oh, this isn't the canary though.
You mean you don't have it?
I have it, but I'm not running it.
Well, 1 second. We'll try.
I don't think touch simulation has landed yet.
Sad Panda.
That's possible.
Well, you could show your laptop again.
Yeah, probably could.
I could just open Canary. I mean, this happens to be stable.
Okay. Yeah, let's do that.
Okay. Here we go.
So there's been a few things landing inside Chrome DevTools that makes it awesome for mobile. And one of them is you're now able to emulate touch events. Well, there's really been no good way to do it. There's been some JavaScript libraries which have tried to like map it over, but now we just have first-class support for it in the browser, and so it's pretty powerful. And so I'll show you now kind of how that works and some of the other mobile features that we have available. Could you dock that baby?
Docked.
Sweet.
Oh, looks like some features.
Oh, check this out. So we also have another feature to show you.
Oh wow, look at this. So many features.
All right. So down in the bottom right, so you open up settings, and then now you have this. You can override the user agent and say that you want the network user agent to be sent out as iOS 5 or any of the other possibilities.
Wait, I know the best feature. Can't you control zoom in on the DevTools now?
It's true.
Whoa, look at that.
This is the best feature, especially if you're presenting the DevTools.
What?
That's right.
And we can do that because it's a web app.
Yep.
It's a web app.
So Chrome DevTools is just JavaScript and CSS.
Oh, yeah.
So Control Planet Pure Plus now zooms. It's pretty newish.
Wow, look at this. Did you know that changing the user agent also sets the dimension?
What?
That actually is really hot.
Wow.
That's really nice. I didn't know that.
Wow.
So this is like basic. So I know when I've done mobile development, right? I've had to.
Yeah.
I have a little JavaScript bookmarklet that opens like my screen to a certain width and height and everything.
Yep.
Maybe I'm doing some UA detection on the server, but this kind of replaces that.
Yeah.
I mean, this is really nice.
Yeah. So we have the device metrics, so you can customize your own view. If I turn it off, kind of just expands it back to the full view. But I'm compressing down the page to match my device metrics, which I can customize. Also the font scale factor and fit window, which I'm not yet sure exactly what it does.
Try it.
Yeah, it does that.
What?
Does that help, guys?
What
Wow.
is that?
That's not a response. Actually, we should bring up a responsive page. Is this a responsive page?
This one isn't.
This is not.
Is there a good
Yeah, just pull up MediaQuery.js.
and just show what happens? And that's another way to do really quick sort of responsive testing is to now use the DevTools to.
Right. So this is pretty cool because in the DevTools I can now set up just change the let's try and go down to 5.
Nice.
Black. What's a small one?
I guess you can't set the.
Well,
Oops.
that works. So we can do that, and also another way to kind of handle your responsive design development is I can just dock to write this entire thing. And if I dock to write by DevTools,
that's great.
I can just bring this over and just squeeze down that content as much as I want. Pretty cool. Yeah.
How did it do that?
Magic.
If you refresh this page, right, does it refresh the DevTools as well? I mean, it refreshes everything.
Yeah.
Okay. Yeah.
Yeah, it brings it all back.
Cool.
So I think what we were trying to show before we got a little sidetracked, guys.
Yeah.
Just so many cool features.
There's a lot of good stuff.
too many to
Emulate
cover.
touch events.
Emulate touch
So I'll turn it off because that's how it is by default. I have this little demo page. It's a Multitouch demo, so you can load it on Android or iOS and just use Multitouch. It draws it on a canvas element, and it works. I don't know. Yeah, the fact that you can do Multitouch in JavaScript and Canvas is kind of not many people know that, but you can tell it doesn't work. I'm clicking on it now and dragging, and there's no touch. But I turn this on, and it's totally working, right, guys?
That's amazing, Paul.
Thank you.
It's because you're painting in white, right? You're painting white lines instead of.
Uh-oh.
Wow, demo fail.
Hold on, maybe it's some sort of. Maybe the internet is down.
This is a feature that DevTools is killing the internet. Brand new feature.
Yeah.
This is simulating offline, man, which is a great segue.
Perfect.
To offline.
So I encourage you to check it out. Emulate touch
Sure.
events. It works, and it works well. when you're
Man, sorry, I don't know what's going on.
That's okay.
It's canary, man.
We'll move on.
It happens.
Dude, you're so...
Maybe your site's down.
My site must be down. That's
Uh-oh.
embarrassing.
That's really embarrassing.
So, speaking of offline,
All right.
we've been moving. One of the big tricks with dealing with offline is that you need a mechanism to store data. And we started off with local storage, session storage, and then there's Web SQL database, but now that's deprecated, although there's variant support. IndexdB is the new hotness, and there's increasingly better support, but it is a mess.
It's a mess.
So,
it's a mess.
But there's some new APIs.
Well, there's one API that I'm particularly fond of.
Which one's that, Eric?
So that's the file system API. So there's an API that's been spec'd out in W3C, implemented in Chrome, been available for a while now, called the file system API. It's my baby. I wrote a book about it. I'll push that. And I wrote a library called filerjs to sort of wrap the library, and you can pretty much call Unix commands, so there's a copy function.
Right, so file system API, just to be clear, is like you can create files, you can create folders, you can move files. Like, think about moving files and folders on a regular file system.
It's exactly what you'd expect in JavaScript.
It's the same thing, except you have a JavaScript API for it.
This is great. So like,
but you can't go to your file system.
Right.
So it's sandbox.
An important distinction, and this is something that always comes up, is you can't just open a file system and read from my pictures folder or my music folder, right?
Yep.
It's very much a sandbox file system, a sandbox view of just your application. So your application can read and write folders and files to this view, but another web app can't access that because of the origin policy, and you can't break out of that.
Yep.
So that's a great distinction to make. But it's exactly what you'd expect, right? In JavaScript, you can write files and store them. You can cache them. It's
big files, too.
Big files. So, I mean, you can store, using the Coda API, you can store whatever you want, unlimited storage as far as Coda is concerned. So this has a real advantage of being able to cache things offline. It is one big use case. Say you have a music app and you want to cache MP3s or something, or files. You can do that and make a folder for all your rock or all your pop music or something, and then delete that at will. So it has some advantages over, say, other offline APIs. I'll point out App Cache is a good example people really hate. It's hard to work with. It's not very dynamic. You have to declare the manifest and keep all those assets up to date. If one thing in the manifest changes, everything's downloaded. That's not great for mobile. That's not great in general.
You can't add anything to your app.
You can't. Right? Well, you can, but you have to change the manifest. But then everything, right? If you're saving
JavaScript, you can't.
You can't, right? Programmatically, you can't sort of say, I want to add this file, I want to subtract this file. You have to work with the manifest, and that's, in my opinion, it's a pain in the butt. So my love for the API is apparent, maybe, but I wanted to sort of help bring the file system API to more browsers. So, like we said, it's only in Chrome right now. But today, actually, I'm releasing and had a blog post about it.
Today.
Nice. Hours before this hangout. It was planned. I'm releasing a library, Peter, if you could switch over to the blog post. It's called IDB filesystemjs, and essentially what it is, it's a polyfill library for the file system API. So the way it works is pretty interesting. I had to wrestle with not only the file system API, so I had to implement that entire thing in JavaScript, but the underlying storage. The reason this works in other browsers is that it can take advantage of indexdb. So indexdb is sort of this up-and-comer. Firefox has it, IE 10 will have it, Chrome certainly has it. Who knows if
it'll be coming in Opera, we expect.
So everyone will likely have the indexdb API pretty soon. But this is sort of my attempt to help that in the immediate future. And filesystemjs is essentially a polyfill, right? So it's sort of how would you explain a polyfill, Paul? A library.
Yeah, it has the exact same API as the standard implementation, just delivered via JavaScript instead of the browser delivering it instead.
Yeah.
So it works the same way.
Yep. So I have a quick demo of this sort of working. If we can switch back to the demo machine. Do you have Firefox, by the way?
Probably an old version.
Okay. I'll show this working in. So this is a demo that I put together. And this demo runs both in Chrome and Firefox. Unfortunately, I don't think Boris has Firefox that we can bring up right now. But this demo would work perfectly in that using indexdb as a storage layer. Maybe he can bring up, yeah. But this is great. So I can write a web app now that uses the file system API, and it's going to work cross-browser. So what this is doing is essentially I can just I have my root folder here. We've opened the file system using our file system API calls.
Sorry.
That's okay. We'll create a couple folders. Test. So this is just using the methods that the API, the file system API implements. So we can create a blank folder, a blank file. I can drill down into these folders. I can zoom. Zooming is good. So you can see I created a folder test. I'm in that folder test right now. If I refresh, my data is preserved. So I still have my folder that I created, my empty file. Do you have any files we can drag into this web app that aren't risque?
That aren't risque. Well,
I don't usually have
You
such
have,
files.
you have like a basic text file or something? Yeah, an image would work great. Some kind of image.
Let's do a big spooky fire.
Big spooky fire. Fires are spooky.
Big spooky fire. My computer is busy upgrading Firefox, I think.
No problem.
Should we just drag it in?
Drag it in.
Whoa.
So using the power of drag and drop,
Nice.
right, we can add that file
that's cool.
right to the file system API.
That's very cool.
Imagine this was in Firefox, it'd be the exact same process. Just to show you that that was added, and hopefully click that and display big spooky fires.
Maybe it's still a big.
We're just completely
Very big.
crashing right now. But this is cool. So now I can use the file system API and all of its benefits in other browsers.
So it's file system API built on top of indexdb. So that means we now have the same API available, first of all, in Chrome, but with polyfill in Firefox and IE10, and any browser, any future browser that supports it,
Yep.
indexdb. So mobile browsers in particular.
Mobile browsers in particular, I haven't. So caveat, I haven't tested in IE10.
I took a look.
You took a look. What happened?
I took a look. I
didn't
put
work?
it in browser stack, and
Browser stack, okay.
I think I saw an exception. Probably not your fault. It's not your fault. But
Don't worry about it.
it might be your fault.
But I want to show. So there's also another demo that I wrote. Oopsie. Yeah, so if you want to play around with the library, go ahead. I'd love to get your feedback, and absolutely, like if you have pull requests or something for IE10 bugs or something, I just haven't had the time to test. But Firefox works flawlessly. They have probably the most up-to-date implementation of indexdb. So this is another demo I wrote when I wrote filerjs, the wrapper library that implements Unix commands. And you can see, sorry for the small screen, but it's the same demo, and it's also now working just out of the box with this library dropped in. It works out of the box with Firefox, with other browsers that implement indexdb. So I can traverse in these folders, as you expect. I can add files. I can import files. I can preview those files.
Cool.
So this is cool. I'm really excited about this. Obviously my passion for the API comes into play, and I think that it's got a lot of advantages over some of the other
Wait, did you say
offline APIs.
that demo is using filerjs as well?
Yeah, so great point, Paul. I didn't say that. Maybe I did. I don't know. But this demo is using the library that I wrote, filerjs.
So it's just like a sweet sugar API.
It's a sugar API on top of the raw file system API.
Like that API, it's
powerful. Good. It's powerful. We all know it's powerful, but it's.
But I would love to just MV and make dir and all that.
Make dir, MV, copy, ls, right? Current working directory, all this cool stuff that you're familiar with. Basically, this library now, the file system, IDB file system, is sitting on top of Filer. So they're working together, and this demo just works out of the box thanks to that.
Hey, so I think Mozilla had some sort of large file support in indexdb.
Yeah.
Do you know anything about that?
So this is what, I think you're asking about supporting binary data inside of...
I think so. They had some specific extension for large...
Interesting.
Sorry. They had a large...
People want to hear what
they
you're
had an
saying,
extension
Boris.
so Mozilla had an extension for large file support, I think, in indexdb.
Yeah.
But I don't really know details.
So this project started off for me as a sort of investigation. If you could store files, it's been said before that you could store files and really replicate the file system API inside of indexdb. So I kind of went down that path, expecting to fail, but it actually turned out to be possible. Firefox's implementation in particular has the ability to store binary data in indexdb, So as soon as I saw that, it opened up, my eyes opened up and said, hey, we can polyfill, an entire API, which is, it's not a small API if you look at the code base.
Yeah.
We can pretty much polyfill the entire API and replicate it using indexdb as sort of the underlying storage layer.
Awesome.
Pretty cool stuff.
Yeah.
So great for mobile, great for other browsers, great for building an app that works offline.
Mm-hmm. Mm-hmm.
That's all I have for me. Do you have time for questions or?
We have time for one question.
One question.
So this came in over the moderator during our conversation. And the question is coming in from Stefan in Berlin. And he asked, I wanted to start a Chrome app based on backbone, underscore, and require. However, the Chrome app manifest version 2 won't allow CSP libraries using eval new, which excludes all known JS template frameworks. Is there a solution for that? This is an interesting question, and I think we're looking into it. Basically, one of the things that we're excited about is getting better CSP support inside external JavaScript libraries. So basically, if you rely on the function constructor or eval, that means that JavaScript library won't work in a CSP environment. CSP is content security policy. It's a new security model. It's pretty exciting, and it's coming. There's good support for it in Firefox and Chrome right now, and Chrome apps will be using it. So basically, I would ask if you have incompatibilities. They have to be looked at the library level. So talk to, try and see if there's a way to work around that. One of the ways in particular with templating in libraries is any precompiled templates are not using eval. Mm-hmm. So precompiled templates are the way to get CSP support.
That's generally a good thing, right? You should be compiling your templates anyway.
Way faster.
Yeah, so it's good for performance. You should be doing that already. This is kind of just nudging, hopefully, developers in the right direction.
Yeah. So that's your solution there. But is that it? I think.
Yeah, I think basically that's a good thing. One thing is, I think Mustache doesn't precompile,
right.
but Handlebars does.
Yeah.
And probably other templating engines do as well. So
precompiling.
Good thing.
Cool. All right. Well, appreciate you guys watching, and
thanks everybody.
We'll be back soon again.
Yeah, we'll see you again.
Stuff coming from Chrome.